Hello, Assalamualaikum. How are you? So today we're going to the next topic, next section, which is 10.6. Now we are going to learn how to solve a first order ordinary differential equation by using a numerical solution or numerical method. We have learned before how to solve ODE using the analytical method or analytical solution. How to solve that is simply by using integration. So when we use integration, we can solve from, for example, dx dt. We can integrate it so that we can get x t, right? So we can get the solution. This is the solution that we want to find. Okay, so that is the analytical method. But in some cases, analytical method is not suitable to be used because it include complex structure, complex problem. So sometimes we prefer to use numerical solution or numerical method to solve the problem, to solve the first order ODE or any ODE. And in this topic, we will learn one numerical method, which is Euler's method to solve the first order ordinary differential equation. Okay, now we are going to learn about the Euler's method. So let's say we have the dx dt equation, dx dt, and we can let this equation equal to a function which is in terms of t and x. Okay, so now it can be any function. It can be x plus t, it can be x square plus t square, and so on. So when we put the value of t and x, we will have the gradient of dx dt, the gradient dx dt. So the gradient dx dt is the gradient of curve of x in terms of t. Okay, so now how to use the Euler's method. This is the concept. I will tell you. First, I'll draw you a curve right here. So this is the graph x against t. So when we want to start a numerical solution, we will pick one point. For example, we can start at 0 or we can start at 1. It's up to us. So let's say we have 1, 2, 3, 4, 5, 6, 7. This is an example. So we want to start at 1 and sorry. Alright. So let's say for the y-axis, which is the x, we just follow the example. So 2, we have 2, 4, 6, 8, 10, 11, 12, for example. Okay, now let's say the first point that we want to use is okay, we want to use the first point is 1, 2, right here. So 1 is value for t and value for x is 2. So it's 1, 2, right? Okay. So what we will do is we only have the function for the gradient of x. We don't know what is the function for x. Okay. So what we will do is we find the gradient. It is similar to the previous equation, no, previous method that I've shown you, which include the direction field. I will show you after this, don't worry.